Greetings peeps! We're going to do this a little different in that I need to show you how to use a particular program to plot data. It's called Logger Pro, and here's the icon that you can find on the laptops. It's a program that's also free for you to download and install at home if you have Windows or Mac. So here we go. Here's what the program looks like. You've seen it before in DanceThatGraph. It's also very powerful to plot data. So I'd like to show you how to do that. Okay, well, first thing we do is we go over to the data set. I'm going to change some of the options here to make it a little easier to read, increase the font size like such. So we can see that it's a little bit bigger over here, and I can move this accordingly so that we can start to read the data. All right, or at least the table, the structure here. Okay, data set is a very generic name, so we want to name it something that's more meaningful. And since we just did a lab on velocity, particularly relative velocity, we used toy, buggy, cars, like this. So we got buggy 1 in this table. We want all the data about buggy 1. And instead of X and Y, which are very generic, what we're going to do is we'll double click here and we open up the manual column options menu or dialog box. So what happens here is that we can put a more meaningful name. So instead of X, I'm going to put the word time because really that's the variable we want on the horizontal axis. The short name would be T, and the coolest thing about this program, in this case, for this feature, is that we can include units. So the units, accordingly, are seconds. You'll see why this is a very nice feature later. Other programs that you are, of course, welcome to use. You can use Microsoft Excel, you can use Google Sheets, but Logger Pro tracks the units, so that's kind of nice. Here we go. Now it replaces the column with a nice meaningful header and the units. For the y-axis, it's going to be position. And we've been using the variable x for that, so the short name will be x. And the units, meters, and so I'll just put an m here. And you can see that's what we have. So in some sample data that I collected, we're going to start with, well, 0.00. That's the origin. At time equals 0, position is 0 meters. Okay, time equals, so this is data over here, so we have time equals 0.5, 1, 1.5, 2, and 2.5. So those are the intervals that data was collected, and this particular run of data looks like this. So 1.48, 2.01, and then 2.51. Okay, so here's the data. If I click on the graph screen, you can see that it's starting to take shape over here. But it's only in this small section. So what can we do to make that look better? Well, we can rescale it. And the cool thing is that we can hit auto scale. Auto scale graph means that it's going to do this automatically and frame the data. So now it takes up the full graph, which is very cool. Well, that's just one car. What about buggy 2? Buggy 1's done. We want to add buggy 2's data. So what we do is go to the data menu and put new data set in. Okay, and so what we have over here, let's widen that so whoop, we can see it. Sometimes with computers, it's hard to grab everything. We obviously want to call this not buggy 1, 2, just buggy 2. Okay, like so. Now the cool thing is that it assumed that we want the same units, and that's true. We do. We just want different data for it. Now the time axis will be the same, so I'm just going to repeat what I had before. Every half a second, data was collected in this particular case. Yours may look a little different in your real data, but this is the data that was collected in this experiment before. Okay, so this time, the position, yes, the star is the same, came out to be 0.25, 0.49. It's a little bit different. This car is actually running a little bit slower because its position is changing not as quickly as the first car, okay? So now the data's in, and we also want to be able to see that on the graph. So right now we only have one car, buggy 1, and its data. So what I'm going to do is go to Options and Graph Options, and you saw me kind of fiddle with this a little bit in DanceThatGraph. What I want to do for buggy 1 is turn on position, okay? And so we can see that here. Now these squares represent the motion of buggy 2. And you can see that the slope is not as steep, so therefore, yes, indeed, it is not moving as fast. We want, though, to look for some more information, some very specific information. So I had you hand draw and create a line of best fit for your two buggies. What's great about this program, and others kind of like it, Excel 2, is that you can go and analyze this information. And what I'm going to do now is, because the cars pretty much, or the buggies went at constant velocity, I'm going to choose linear fit. I can also choose curve fit if we have some data points that are outside of a line, or if they tend to curve, but I'm pretty sure that this looks fairly linear. So I'm going to choose buggy 1 and buggy 2, and boom, what I have is our two boxes here that indicate some information. And with each box, I'm going to go to options, linear fit options, and I'm going to click on appearance and make the font a little bit bigger so we can see it better, like say 22. And I'm going to change the color so that it's something cool like pansy, the pansy color. Okay, a little purpley like that. And so there it is. Do the same thing for the second graph here, and click on appearance. I'm going to go raise the font size and choose a different color entirely. I like hunter green. Okay, here it is. All right, these boxes point to particular graphs, and they tell us some information. First of all, here's the equation of a line, y in the form of y equals mx plus b. Now, what this says here is that x, which is the position, that's the variable we chose for position, equals mt plus b. Okay, well, the slope, as we know, is m, and t is the time axis. Okay, so this takes on the typical equation of a line. And what's really cool is that we know what the slope is. The slope is 1.004, which is about 1 meter per second. And look, it has the units right here, meters per second. That's really cool. It also tells us something about the correlation. The closer to the number 1, the better this data fits the shape of the line. Okay, so your data is linear in this case. 0.99 is very, very close to 1. And it also gives us a root mean square error, which is another statistical value. In the case for buggy 2, here we got the same equation. However, the slope is 0.5051. So it's about half of what it is over here. This vehicle is moving at half the velocity of buggy 1. So buggy 2 is slower. Correlation is also beautiful, very close to 1 at 0.9996. Okay, so with this information here, we have used the slope to determine what the velocity of the vehicle is from the original data over here. All right, terrific. What I'm going to show you in a next video is how to use this information to plot it in such a way where we can then look at situations with relative velocity and predict with a head start, if we give buggy 2 a head start, where they're going to meet. So hang on.